All right, let's look at some more definitions. I defined earlier what a coterminal angle is, but just to be clear, a coterminal angle refers to two angles in standard position that share the same terminal side. And a new definition is an angle's reference angle. An angle's reference angle is the size of the smallest acute angle formed by the terminal side of the angle and the horizontal axis. Now, what is an acute angle? An acute angle is an angle that's between 0 and 90 degrees. So try to remember that. So let's look at this graph here. It says to identify a coterminal angle and a reference angle in this image. So we have an angle of 225 degrees, and that's positive because we're starting with this initial side and it's going counterclockwise all the way into quadrant 3. So a coterminal angle would be an angle that shares this same terminal side. That's all that has to happen. So there's actually quite a few possibilities here. We could, let me switch colors to a different color pen. I think maybe to me the most obvious would be starting on this initial side, but instead of going counterclockwise, going clockwise. Now by going clockwise, I've just created a negative angle. And what would that angle be? Well, let's see here. So we know that the whole circle is 360 degrees. So we had 225, so 360 degrees minus 225 degrees leaves us with 135 degrees. I think that's right. And because we are going clockwise, that makes this a negative 135 degree angle. That angle would be coterminal. Now I said there were a lot of choices, and that's because I could just keep going around and around and around the circle, adding 360 degrees, adding 360 degrees. So maybe another choice could be starting with the 225 degrees, and if I add 360 degrees, I would end up with, let's see, 585 degrees. That would also be coterminal. That would just be the situation where instead of stopping right here, I go around one more time. All right, a reference angle. It's the size of the smallest acute angle formed by the terminal side of the angle and the horizontal axis. Well, here was the terminal side of the angle. I've made a mess on this picture, but here's the terminal side. And so the angle that is formed, the closest angle that is formed between that terminal side and the horizontal axis looks to me like it's this angle right here. Now we know that from here to here was 180. And so that difference must be 45 degrees. So 45 degrees would be the reference angle. Let's look at another example. Part A says to sketch an angle of negative 170 degrees in standard position. Part B says to find a coterminal angle for negative 170 degrees. And part C says to find the reference angle of negative 170 degrees. So to begin, I am going to go ahead and sketch a circle on an XY axis so that I can draw in that negative 170 degree angle. So there is my circle, something like that. That's not bad. And let's see, I'll do this in yellow. It says standard position, so I'm going to have my vertex at the origin, and I'm going to have my initial side on this positive x-axis. Now, where is negative 170 degrees? I know because it says negative that my angle is going to open up, what is that, clockwise? And I'm not going to stop there because that would be negative 90 degrees. If I go halfway around, that's going to be negative 180 degrees. So it looks like in my situation, I'm going to stop just short of that negative x-axis. So it's going to look something like this. Okay, so make sure that you agree with that. I've got two arrows on there, but it's really just that whole thing. This whole space here, I'll call that theta. That theta is negative 170 degrees. Okay, so I took care of part A. Part B says to find a coterminal angle of negative 170 degrees. What a coterminal angle is a different angle that has the same terminal side. So we've taken care of really the bottom half of the circle. What if I were to go from the positive x-axis, but instead of going clockwise, I moved counterclockwise? So I did something like this, right? Whatever that angle is, that would be coterminal. Well, let's see. That would be going halfway around and just a little bit more. What was that little bit more? Well, we went from negative 170 degrees to negative 180 degrees. So this angle that's on the inside here, that was a 10-degree angle, wasn't it? It was a 10-degree angle. So my angle that I've drawn in red, that would be whatever 180 is plus 10, so that would be a 190-degree angle, right? Is there another solution to this? In other words, could I come up with a different coterminal angle? Well, if you recall, one full revolution around a circle is 360 degrees. So I really could, I'm going to make a mess here, I really could just keep adding 360, or I could take away 360, and I would just keep going around and around and around that circle. So other solutions could be negative 170 degrees plus 360 degrees, or negative 170 degrees minus 360 degrees, or maybe I even want to get crazy and keep adding 360 and keep taking away 360. Okay, so in other words, I'll put a dot, dot, dot here. There's a lot of solutions. And that's one of the reasons why you see me use the word A, because there's more than one. All right. On a test or a quiz, I would have to be specific with you, and I'd also have to be flexible. If I was looking for any possible coterminal angle, I would have to check any sorts of different answers because there is more than one. Now, for part C, and I'll just go ahead and check that we took care of part B. For part C, it says to find the reference angle. That means there's just one. Now, if we go back to that negative 170-degree angle, the reference angle is from the terminal side of that angle to the nearest x-axis. And I believe that we have already written what that angle is. That 10-degree angle, is what we call our reference angle. Now notice that the reference angle does not have a sign attached to it. The 10 degrees is the 10 degrees is the size of the angle. We don't care about the direction of the angle when we talk about a reference angle. So 10 degrees is going to be that reference angle.